Hello dear students and welcome back to functionalstudies101.com. Today we are going to be looking at the chain rule. Okay, it is used in differentiation of special type of function which are composite functions. So make sure you follow up the lesson properly. So this is a test series in differential calculus. Okay, last time we talked about differentiation of tangent of x from first principle. Today we are going to continue with techniques of differentiation where we look at the chain rule. Okay, to get to me, you can use the number on the screen, you can send me a text message on WhatsApp and I'll reply you. So if you are new to this channel and you don't know me, I am Temgun48 presenting the script. You can call me that. And don't forget to subscribe and turn on the notification bell so that whenever new uploads are made available, you will not be left out. Okay, so without wasting much of your time, let's get started. So what's the chain rule? The chain rule, as we said, is used in differentiating composite functions. That's function of a function. Okay, that's a function whose input is not just x but a function of x. So this is an example of a composite function f of g of x. So the input to this function f is another function g. So we have functions of this nature. To differentiate them, we'll use a chain rule, and the chain rule says that if we want to differentiate this function, we will differentiate the function normally, treating this g of x as if it was just a simple x. Okay, take note of that, treating it as if it was just a simple x or a single variable. Okay, so that means my y prime, since it's a function of x, okay, y is a function of x, and we say it is customary to write dy by dx as y prime. Whenever you're differentiating any variable with respect to x, you can replace that variable, that the differential coefficient of that variable with respect to x as that variable prime. So since it's y here, we use y prime as a short form. Okay, if you wish to write dy dx, no problem. Now looking forward to this other looking forward to this part, we now have to analyze why it is like this. The chain rule says we differentiate this function normally, okay, as if this one was just a single variable. You could replace this with a single variable, then now multiply the function by the differential of what is inside the function, okay, g prime. That's the chain rule. We'll take an example, 3 examples to see that. So for beginners, alright, if you want to know how this is derived, look up. So if u is a function of x or g is a function of x, you call this u is a function of x. Okay, we call, so the chain rule says we call this a single variable, consider it as a single variable. It means that our function will now become f of u. The next thing now we have to do what? Look for the derivative of this function. So when you look for the derivative of y with respect now to u, are you seeing that? So you are differentiating y with respect to u, so that's dy du. Notice that we don't just write y prime because what? The variable at the independent variable is not x, so you don't write y prime. If it's something else other than x, you have to write it down. Okay, except for special variables like when it has to do with time, where you can use the dot notation. I will show you that in the subsequent lessons. So since I'm differentiating y with respect to u, so that's this one, dy on du will be equals to what? F prime of u. Then now We also have to look for this derivative u. You differentiate u with respect to x, du on the x now, because u is a function of x, which is equal to g prime of x. Then now the chain rule, according to fractions, we know that we can write dy by dx as dy by du. Wow. Look at the way we are introducing something new. Dy by dx is same as dy by du times du by dx. Since we have introduced, because we want to create this term, right? We want to create this term. So we just write this at the denominator times this other one, du on dx. The du's can cancel. Are you seeing that? Because this is a new variable we have introduced into the expression. So we write it in that line. Or in other words, if you don't understand, just write dy by dx as a product of this, alright, the two derivatives that you obtain from this line, dy by du times du by dx. So that's exactly it. So if you cancel, if this can cancel out and you'll be left with dy by dx, so this identity is correct. Alright, so from there now we just have to replace. My y prime will now be what? Dy by du is f prime of u times g prime of x, which is du by dx, g prime of x. Then now finally, we know that u is equal to g of x. We can just replace u by g of x. So that's how the identity is working. So just know the chain rule. The rules that you have learned to differentiate functions, they will not change. Okay, they will not change. So when you are differentiating a function using the chain rule, apply your differentiation normally. You differentiate a function as if observing whether it is a power function or it's a trigonometric function and other rules that you have learned. Okay, whether it's a radical, once you know the nature of the function, the general function, from there you'll be able to know what to look for the derivative of that function according to the chain rule. So we'll differentiate a function normally as if this g of x is a single variable, without caring about its nature. Then now finally, when you do that, you are not done. You have to multiply by what? The derivative of what? The function that is inside this g of x. That's g prime, the derivative with respect to x. Finally, from here, okay, from here, and also I want you to know that the reason why I wrote f prime of u, remember u is a function of x. That's why if you are differentiating f prime of u, if u is a function of x, then f of u will also be a function of x. That's why that allow us to write f prime of u. So I hope you understand this formula. Keep it simple like that. Let's take some examples so that we understand it better. So we're going to look at this example. We have to differentiate with respect to x the following function: y equals to 3 plus 2x raised to the power 6. When the power is just 2 or 3, some students will say, let's just expand and differentiate. What if the power is now large? That is where you use a chain rule. Are you seeing it? This is a power function. Are you seeing it? This is a polynomial. Normally, polynomial. A polynomial of degree 6 when you expand it. But we'll not do that expansion here. Okay? So what if the power is 20? Do you think you'll be able to expand? No. This is where you use a chain rule. Okay? You see that this is like a power function. Okay? A power function. So it means that what? There is a function that is inside this power function. Okay? So in that case, we will call this function, we will differentiate this. Let's first of all follow the steps. We will call this function to be u, the function that is inside, according to the chain rule. So we call this my function y, then I will call the inside function u to be equals to what? 3 plus 2x. From here now, my y will now become u raised to the power of 6. and I'll show you why I was explaining that in the other video, the other slide, sorry. So from here we know our dy dx, is dy du times du dx. When you make this substitution, just write down your formula, okay, and I will show you why. So now where you differentiate u with respect to x, what do you have? Because we need this in this formula now, u with respect to x. Differentiate constant is 0, so you differentiate 2x is 2. I told you that when you are differentiating a function of this nature where the power of x is 1, you just copy the coefficient only, the coefficient of x, and you are good to go. Then I'll differentiate y with respect to u because y is a function of u now. So that will become dy du because what? So this is a power function, it will become 6u to the power of 5, 6 minus 1, sorry. There is a 6 minus 1 here. Okay, this is 6 minus 1. I wanted to indicate but I forgot. So this is 6. You copy the power where I differentiated a power function and reduce the power by 1. I've corrected it here. Okay, so that's u raised to the power 5. You take note of that and correct it as you follow along with a piece of paper. Now all we need to do is just to apply in the formula. Dy du is equals to what? 6 u raised to the power 5. I have told you that this is 5, not 6. Multiply by du dx. Du dx is 2 now, so that will be 2. Then at the end of the day we end up with what? 12u to the power of 5. But my u is equals to what? My u is equals to 12. My u is 3 plus 2x. So you just replace in that position, and then everything is raised to the power of 5. I hope you understand. It's clear. Okay, now look at why I was telling you that you don't need to go through all this substitution if you are a wise student. Differentiate the function as if it was a power function. It means that we'll have to copy this power in front of the function. That will be this 6. Then we'll reduce the power of the function now by 1. So we'll be having 3 plus 2 raised to the power 5. This is it now. Then now we'll multiply the function by what is inside, the derivative of what is inside. That's a chain rule. Learn this trick because this is what you need to know. Using the substitution is good, okay, and accepted, but after learning it and knowing how the chain rule works, you can just be applying it directly. You don't need to do all the substitution when you are given a question to solve. Even if you write down the answer straightforward, they will give you all your marks. If you go through this long procedure before you get the answer, they will still give you exactly the same marks. So don't bother about that if I use this method it's too short. No, even if the question is for 20 marks and you do this and you get the answer like that, is very correct. So that one will now be 2 times that 6, it gives you the 12 automatically. So you see how you apply the chain rule directly. So that is it. We'll now look at the second example. So the second example, we will be very fast with this. So we have to differentiate with respect to x the function y equals to sine of ax squared plus b. This is a quadratic whose the coefficient of x is 0. A and b are constants. Okay, in this example, take note of that. So in the same way, we let y to be equals to that, and from there, what you notice that this is a sine function. Okay, the general overview of this function is that it's a sine function. So it means that this thing will now exist like that. Are you seeing it? My first observation is that it is a sine function. I know how to differentiate a sine function, but now inside the sine function there is another quadratic, a function, a quadratic expression. That's another function. Okay, so it means that is a function of let to be u. Let u to be that function. Then now my y will now become sine of, because you replace this by u, you left with what? Y equals to sine u. Okay, That's why we have this. Then again, we differentiate y u with respect to x u prime. Okay, du dx is equals to, when you differentiate this, a is a constant. When you are differentiating function like this, you just keep the constant and differentiate only the x squared. Okay, derivative of x squared with respect to x is 2x. We already know that now. Yes, so it's 2x, so 2ax. Then now differentiate b is a constant, so when you differentiate a constant, it gives you 0. Then now you differentiate y with respect to u, that will give me dy du equals to, when you differentiate the sine function, you get the cosine function. Okay, so finally we end up applying our formula, which says dy dx equals to dy du times du dx. Dy du is cos u, and du dx is 2ax. Finally, we have to just replace our u. U is equals to what? As squared plus b. So that will become 2as cos u, and then you replace your u finally, and that is the final answer. So look at how I told you can solve this question smartly. When you differentiate the sine function, what do you have? The cosine function of that same thing that is inside now. Cosine of that thing, whatever is here, that's generally the derivative of the sine function is a cosine counterpart. Finally, from there, we are not done. If you are applying the chain rule directly without going through all this long procedure, just know that I just write cosine, derivative of sine is cosine, but I'm not yet done. I have to multiply by the derivative of the inside part. When you differentiate this inside with respect to x, you have what? 2ax. That's it there, and you are good to go. You don't need to do all the substitution. It's necessary if you want to, if you cannot reason it this way or do it directly, you can go through this long procedure and get to the same answer. So we look at the third example, and finally the last example in this tutorial. We have to differentiate with respect to x the function y equals to sine of x squared plus square root of 1 minus x squared. We know very well that this is still a sine function. Okay, that's our function to be differentiated. So inside this sine function, there is another function inside. Okay, are you seeing that? So this function, the sine function here, has input, which is another function. So we'll let u to be that function that is inside, and then my y will now become sine of u. From there, we'll have to let u to be this one. We'll simplify it a bit, knowing that the radical can be written as that thing inside raised to the power half. Square root of 1 minus s squared is the same as 1 minus s squared, all raised to the power half. From there, now we have to differentiate y with respect to u. We know is cos u now already. Then now differentiate u with respect to x. Where you differentiate x squared, you have 2x. To differentiate this a power function. So you have already learned the chain rule. In this example, to differentiate this part, we apply the chain rule, because you notice that what you have to notice here is that it's generally a power function. Okay, it's a power function where the power is half. So I copy the power in front of the function and then reduce it by 1. So half minus 1 is negative half now. So that's why I have this negative here. But I'm not yet done, since I'm applying the chain rule in this part. So I have to differentiate again now, multiply by the derivative of what is inside directly. So you see why it's good to know how to apply the chain rule. Understand how it works, so that you will not be doing substitution all the time. Because here you are applying the chain rule, I have to do another substitution again. You have to introduce some new variables, which will make the work lengthy for nothing. So just know that, recognize that this is a power function, and inside this power function, this is a radical now. Okay, there is another function that is inside. So the input of this radical is a function. So this is my u, if you want to do substitution, and then now this one will be my square root of u will be my y. You have to differentiate, follow the step. So directly, just to write it like this is a power function. I know when I differentiate I have half in front, and then I will use the power by 1 of that same thing. Then now I'm not yet done. I have to multiply by a derivative of the inside function. Okay, 1 minus x squared. Where is differentiate 1 minus x squared? You have minus 2x. Then now minus this one and this one will multiply to give us this half, and this one will cancel out. And then now this is now let's apply some loss of indices there. So you have 2x minus x times this, right? Because this 2 will cancel with this 2. Then now you'll be left with this. Then now, according to loss of indices, this man can go to the denominator and the power becomes positive. That's the u on the x. Finally, we just have to apply the formula dy dx equals to dy du times u dx. Dy du is equals to what? Dy du is equals to cos of u multiply by all of this part du dx. Finally, we all need to just rearrange, send the cos to the back, and then we'll replace our u by its expression. So my dy dx is equals to 2s minus x over 1 minus x squared raised to the power half times everything multiplied by what? Cosine of what? S squared plus 1 minus s squared, all raised to the power half. Or just if you wish, you can just copy this and come and put it. It's the same thing. So that's the end of it, and I'll leave you guys now with this assignment. So make sure you do this assignment. It's very, very important for you to practice. Do all of this assignment, and you can take my number on the screen and submit it on WhatsApp if you need me to cross check your work and show you some further tricks. And also, yeah, what I wrote here, right, it was actually the sine function all squared. But also I would like you to do it like this: y equals to sine of x all that squared. That's what I intended to write there. And also I would like you to treat it as you are seeing it: y equals to sine of x squared. Those are two good questions that you can attempt in this part. Okay, yeah, so that's the first exercise. You do this other one as well. They are not difficult if you follow the explanation in the video. If you don't understand anything, feel free to replay the video again until you understand. Okay, so I want to thank you all for your kind attention. Hopefully you have liked the video, and please share it to others. Subscribe is very important for me to continue creating more wonderful content for you, and don't forget to turn on this bell icon so that whenever I upload a video, YouTube will notify you instantly and you will not miss out on any important thing I've uploaded. So thank you all for your time, and hopefully to see you in the next tutorial. Bye bye and stay blessed. This is Dr. Tem signing off.